Testing 1, 2. Okay. This is a short, not really tutorial, but kind of a walkthrough of how we use MySQL Workbench to do database design. So the first thing that we'll start out with is we have to rename the schema to something that is not MyDB. So we'll click Edit Schema, and we're going to call this Test CRM. So Test CRM is going to hold on to a couple of pieces of information for us. We're going to have companies, contacts, addresses, emails. The biggest thing to understand is we need to ensure that foreign keys do not allow bad data to be inserted, that they also allow us to prevent data from being orphaned, and we also need to make sure that we're being very careful to take care of the one-to-many relationships that we have. So anytime that you would have a repeating column like address 1, address 2, address 3, that really should be its own table. I mean, that's standard database design 101 stuff. So let's first start out by creating a diagram for this. It is easiest to create this from a diagram. So we'll click Add Diagram, and we'll start out here. Usually by the time you get done working on this, you will have come up here and come to, where is it, database. It's a little bit different on Windows than it is in Linux, but diagram properties and size, and you will have probably made this a 6x6 or an 8x8 or a very large diagram, but we'll start out with just the single page diagram. We're not going to get too many tables in here. So the primary thing that we think about when we're designing a database is what is the most important piece of information. So in a CRM system, it's customer relationship management, the people are going to be the most important things. Now, people generally belong to a company, but because a person could go from one company to the next, then companies would be secondary. But let's talk about creating a table here. Now, I've just grabbed a table. This is going to be our people table. I tend to name all tables in the plural. So this would be people. And then we'll add in columns. Obviously, when you start out here, it says ID people. That is the default. We definitely want to change that. It's in Preferences. Edit, Preferences, and come here to Defaults. And let's change this from that to _ID. We do want that to be an int. Column name would be whatever it is, underscore column. Let's make sure we get the underscores in there. Our default character type is varchar 45 is fine. Foreign key we can leave as it is. On update should be cascade. On delete should be cascade. And so this will be our defaults for pretty much everything that we do. So now when I come back here and I come back to column name, you can see people ID is already there, int, and this will be a primary key auto increment. So the next thing I want to track obviously is their first name, last name. First 45 characters should be enough for a first name. Last, date of birth, we'll change that to a date time field. And then another one that is extremely useful is the timestamp. So we'll just call this a timestamp. And we will change this to, maybe it's date time. I think it's actually date time. We'll change it to date time, and then over here in the defaults, if you right click this, you can see that there are some pre-chosen defaults for us. So we're going to do current date on default, current timestamp, on update, current timestamp. So that will, that's our timestamp. And then we also want to have one that is created. So we need to know when it was created. The reason that we care about these things is occasionally you have to do data cleanup, and it's very useful to know when a record was created and how current the record is. So for this one, I'm going to do default current timestamp, and then we're going to be done. So right now, when we create a person's record, I'm just going to save. Oh, yes, this actually should be saved in a Git repository so that it can be versioned. But for now, I'm just going to stick it on my desktop and be done with it. So now we've created our people table. Very simple, very straightforward. We need to create a company table. And a company, and that's automatic company ID, primary key, auto increment, and then company name. And then we have our timestamp. You could also call this modified. In fact, I'm going to change this to be modified. in the people table. Let's go and change that so it's, instead of timestamp, it's modified. Does that make more sense? So a company with no people doesn't make any sense. And people who don't work at a company are, well, broken poor. So we need some people that work at a company. So we're going to create another table called company has people. And this is going to set up our one-to-many relationships. So I'm going to grab these identifying relationships. We generally want to have identifying relationships between them. And so the first thing here is that company, this is getting linked over here to our primary key for company. So I'm going to turn around and do that again for people. So I also need to have an individual key for this, a primary key for this. So I'm going to do company has people ID, which is a primary key, and it's upset because I need to put this at the top. So let's move up, auto increment. It also needs to be a integer and auto increment. So what this does is this allows us to have these relationships with these foreign keys, and it allows us to do queries later on the company has people table instead of us having to do a join between company and people, and that increases performance. So let's go back now and look at a few other things that we need, because this is a one-to-many relationship. One company may have many people, and one person actually could be associated with more than one company because of the way that we've got this set up. But we also are going to need some addresses. Now, an address would be the same for both a company and a person as well. So we essentially create another table that holds addresses. So we'll call that address, address ID, primary key, and zip. And we know that zip codes in the United States are 5 characters long. So we're going to put 5 there. So 30188, yeah, 5 characters long. The state is going to be a 2-character abbreviation. So we'll drop that there. Cities, suite, street, all the rest of that looks like it's good. And so now we have this address field. And addresses, you know, a person has an address. They have a home address and an office address, and companies have an address. So we end up creating a table called company has address. And we'll go ahead and create that ID first on this one, which I didn't do before. And then we'll use some identifying relationships to build that out. Oops, I accidentally did that to people. Let's delete that. Yes, we'll delete the underlying relationship because that's what we're intending to do. So we'll do a one-to-many relationship here. So now we have companies have addresses, and we'll end up with the same table here for people. Primary key, auto increment, and then we need to get our identifying relationships going so that, you know, people will have addresses. Now notice what happened here. I did this on purpose so you could see what's going on. So notice what happened here. When I did this, because I've got primary keys and identifying relationships here, when I added in people has addresses, we end up with these company addresses also, which is not what we want. So let's go back and change the type of relationships that we have. That's identifying, but let's make this not identifying. Company has address. Whoops, both of those were backwards. So now if you see, we can see that this no longer has that identifying relationship. In other words, it's only referencing the primary key in the address table. Now it's nice that we have these other keys, but they're not really necessary, and they're left over from when we had that that relationship, that identifying relationship. So we're going to go ahead and delete those. because they're not necessary. So now we have that and we have that. And that's nice and clean. It means that we only have to write one class that deals with addresses. We only have to write, we only have to maintain one set of address lists, and we can actually do some work to dedupe things in those areas. So now we've created this. We have people. So if I just put my mother in there and her address, then this database supports it. If I put in a customer in here and his home address, it supports it. If I use that same customer who works for a particular company and I have that company's address, it all supports it. And so what we've done here is we've illustrated one of the really important things that we need to do, which is create as simple of a table as possible. We need a minimum number of tables, but we don't want to have so few tables that we end up having to duplicate and recreate work. So this is the first thing that I wanted to illustrate in how we do database design. Now the next part, let's go ahead and save this. So the next part is, look, we have to think about search. What are we going to search by? Well, if I'm looking at a company, because searching needs to be indexed. So if I'm looking at a company, I'm probably going to end up searching by company name. So this should be indexed. So we're going to come down here and open up the indexes. Now let's just go ahead and add, it will be just an index. We just need a B tree and company name. So also now for the primary keys, we'll have that also, but that's our primary, there's our index. So now when we search by names, the names will be indexed and our search queries will come back much faster. It's possible that we would search by created or modified dates, but unless that's going to be something that we search for all the time, we won't really need to index that. The more things you index, the larger the IBD data1 file will become, so we need to be efficient with what we index. Now with people, we are definitely going to come back. Let's do IDX first is an index. We're definitely going to be searching by first name. We're definitely going to be searching by last name. So we definitely need to index both of those. Now this has addresses and company has addresses. These are all going to be completely numeric values. And since they're all primary keys, the indexing is already going to be done by itself. So, if we really needed to boost speed for whatever reason, we could come back and re-index those, but we're going to leave it as is. It's also very likely that we're going to search by zip code and probably by, let's say, state, because we won't necessarily know the street, but we could say I need to know all the companies that are in such and such a state, or all the companies that are in a particular zip code, or all the companies in a particular city. So we can add those in as indexes. And you could index those like this. You could do IDX location index and then put in multiples, but that's not really appropriate for this particular application. Now, one thing I forgot to mention, but is very important for you to do, is to make notes as to what each column does. So when I come here and I've got first name, the comment should say something like holds contact first name. We should be doing the same for last name, contact last name. And also DOB, we need to know what DOB means. So holds contact date of birth. And again, modified, the timestamp when this record was modified or updated. And same thing for created. Now this looks very simple and it looks self-evident, but there is a lot of times where you go and look at a database that was designed by someone else and you're not real sure what those columns were. This becomes very important when you're trying to figure out a query that needs to be updated or modified. Now, one of the other items that we need to make sure that we do is put in what our indicator values are if we have any sort of flags or switches. So right now we're on the table database, and let's go ahead and put people sex. And I need to know, this is varchar 1, it's going to be a choice of one or the other. It's either going to be male or female because we only have those two. Now this seems rather obvious, and it should be obvious because we are doing a very simple explanation here, but in other applications where it's not so obvious, this becomes extremely important. So I will say possible values M equals male, F equals female, and now we've saved it. So that's a really important thing to put in there, because when all else fails and we're trying to figure out a particular query to either update it or deal with it, we may need to know what all the possible values are so that we can create a query to find something, especially if we're doing data cleanup. Now, the last thing I want to show you in this introductory walkthrough is how to synchronize your model with a database. This is probably the most important and nicest thing about working with MySQL Workbench. So if I use Control-Shift-Z, or if I come up here to Database and go to Synchronize with Model, or Synchronize with any source, you can use that one also, and that's a little bit more advanced, but we'll do that later. But let's do Synchronize Model. It's going to ask me which connection I want to use, and I've got a test connection here that I'm going to use. And then we click Next. You can check these as needed, but I typically leave them blank. It will connect to the database. It retrieves the existing schemas, and then it looks for any config issues. Now, this is the schema that we're going to synchronize, and we just created it, so it doesn't actually yet exist on the database server. So you can see schema not found in target. And then we'll go ahead and tick that one because we are going to work on that one. And click Next. So then it goes and it takes a look to see what is in the schema on the database compared to what is in your model. And you can see here our model has a bunch of stuff, but source, meaning the database server, has nothing because we're about to create everything. Then you click Next, and it gives you an opportunity to review the SQL that it's going to use to create those things. This is very useful if you want to create a SQL file that you can include in a PHP Ant app that needs to create a database for some sort of a setup. This is very useful. You can copy paste this and save it to a file, or save to files right here. And then we hit execute. It goes and executes, and boom, it's done. So now if I go and open up that server, you'll see that we just created that schema, and here it is. Test CRM is right there with our tables and our addresses and our columns. So I can come here and I can hit this, and I can see everything's empty, but we created the schema. So that synchronization is ridiculously useful. But now let's say that we want to make a change. For example, we want to add a field to company, and we're going to go company revenue, and revenue should be a decimal because we're dealing with money. And then also, we've decided that we're going to add in a table for email addresses, and only people can have email addresses, right? So we'll add in a table for email addresses. One thing to note here that I've created the email address. I'm using varchar 255 because that's the maximum length that an email address should be according to the RFCs. But I've also checked unique. We should not have more than one person with the same email address. Email addresses should be unique. And then lastly, I'm going to create an identifying relationship. Oops, that's backwards. Here because email addresses belong to people. And now I'll hit save, but I've made some changes and I've updated the schema. Well, the nice thing is, if we do the synchronization, again, that's Control-Shift-Z, next, it connects, it goes and it looks, it finds that we do indeed have that schema because we just committed it a few minutes ago. But now it's going to diff the schemas, and we can see that people will remain unchanged, company is going to be changed, and it shows you what the addition is going to be. Same thing for company has people. We've altered that, and it's going to drop the index company has people company. And also, we're going to be adding this email here. So when I go here and click Next, it will execute all of this and bring it up to date. Now, it's common that sometimes you'll run into this issue where there is a foreign key constraint that's been changed, and it therefore won't update. And if we go and look at the index, here it is, we can see that it's actually been renamed. So that's kind of an issue. So we can go, well, the easiest thing here is probably going to be to remove the foreign key and re-add it. So let's go and find the foreign keys. That kills the index. And then I always do that backwards. You click on the one that's supposed to have the key first. And let's see if that synchronization works. And it did. So just deleting those keys and re-adding them in fixed the problem because they had accidentally been renamed. And that's a common issue. You'll be working on a database schema, you'll make a bunch of changes, you'll go to commit the changes, and it won't let the changes commit because there's been a foreign key that's been upset. And because I understood what the error was, I was able to hit ignore and then come back and fix it. But if you don't know what the error is, you shouldn't hit ignore because you could completely blow up the database and cause yourself a whole lot of extra work. It's much easier to go back and fix the problem so that everything will work. And a lot of times that means going and deleting and re-adding the foreign keys in your model so that when you do the commit later, you're not destroying anything.